Now we're going to take a look at some mathematical models. We're going to try to use mathematics to model real-life situations. There's a couple foundational principles that I want to we'll sort of go over before we do some examples. There's really three things I want to talk about. The first is going to be the distance formula. Okay, it's going to show up quite a bit in this course, and it does have a lot of applications, and so we're going to talk about that first. It may be something you're familiar with, but I want to review it. The distance formula is the distance between 2 points, and if you were a straight line distance, and so if you were to draw a line between the 2 points, what's the length of that line segment? That's the distance formula, or that's what you'd be looking for. And so if we know the coordinates of the points, we can find the distance between them. Okay, the first point here, I'm going to label it as, maybe I won't put an arrow there. Let's label it as, I'll just write it over here on the side, x1, y1. And the second point up here, I'm going to label that as x2, y2. Okay, so there's 2 points. They have both of them have x coordinates, both of them have y coordinates, but we designate them as x1, y1 and x2, y2. The subscripts just sort of separate the 2 points off. Okay. Now this first point then would have an x value of x1 and a y value of y1, right? So that's where the x1, y1 end up on the graph. Similar for the second point over here. We have a point here at x2 and a point across here at y2. All right, so we have 4 different numbers essentially on the graph. Now, they don't show up as numbers, but essentially we could treat them as numbers. Now, how do I find this distance using those coordinates? Well, you probably remember the Pythagorean Theorem. The Pythagorean Theorem would say that for any right triangle whose legs are length a and b, and whose hypotenuse is c, then a squared plus b squared equals c squared. Okay? We're going to use that formula, and we're going to build it from these 2 points. Okay, so here's how we're going to look at it. We're going to sketch in a right triangle. Maybe I'll put that in another color. So you can see there's a green triangle up here. The green triangle then would be the right triangle that I'm referring to, and it has side lengths. We'll call them A, B, and C. Okay. Actually, I'm not going to call it C. I'm going to call it D for distance. Right. That's the distance between the 2 points. That's the hypotenuse. But I'll go ahead and put A and B down here. A is the horizontal side, and B is the vertical side. So how do I find all these different side lengths? Well, the side length A is going to come from the difference between the 2 points, right? So if we took x2 and subtracted x1, you'd get the distance between them of A. All right, so let's put that up here. So A equals x2 minus x1, right? Similar for B. The length of B is going to be the end point minus the initial point. So y2 minus y1. The difference between the two gives you their distance apart. So B equals y2 minus y1. Okay. So there's my 2 side lengths. Now the third side length, the hypotenuse, is the distance. And so when I plug all these things into the formula, the Pythagorean Theorem, I would get this expression. And I'm going to actually write it with the hypotenuse first. So it's going to be d squared equals, well, a squared is this quantity here. So it's actually x sub 2 minus x sub 1 squared. That's your a squared. And then you add to that b squared. Well, b is y sub 2 minus y sub 1. So there's your a squared plus b squared equals c squared, or I'm putting d squared again, okay? And so then to find the distance, we just take the square root, and we're going to use the principal square root, right? The positive one, because it's a distance. I don't need a negative root there. So the distance then is the square root of x2 minus x1 squared plus y2 minus y1 squared. All right? This formula does not simplify any further. And so it gives you the distance between any 2 points if you know the coordinates of those points. So you subtract the x values, square that. Subtract the y values, square that. Add the two numbers together and take the square root. Okay. We could do just a very, very quick example. If I was looking for the distance, let's say the 2 points were 1, 3. Let's make that look like a better 1. 1, 3, and let's say 6, 13, for instance, something. Then the distance formula, again, you would just subtract. First step is to subtract the x values. So you'd have 6 minus the 1 squared, and then you subtract the y values, so it'd be 13 minus 3 squared. Okay. When I plug all that stuff in, or when I calculate it, I'm going to get, what's this, 5 squared is 25, right? 6 minus 1 is 5, square that, you get 25. 13 minus 3 is 10, square that, you get 100. And so that gives you the square root of 125, okay? Square root of 125. Well, 125 is not a perfect square. It is a perfect cube. It's 5 times 5 times 5, which would allow me to simplify this root. It is 25 times 5, so I could simplify it. And I could call that, what, 5 times the square root of 5. You remember, when you simplify a root, you find a perfect square factor, and then you split the root between that and the other factors. So you take the square root of 25, that's 5, and then the square root of 5 doesn't simplify. So 5 root 5 is also equivalent to the square root of 125. Now, what is that in decimal form? Well, I could go to my calculator and I could just plug that in. Either one. I could do square root of 125, or I could do 5 times the square root of 5. Either way, it wouldn't matter. And what I'm going to end up with is approximately 11.2. Okay, it's 11.18033,989, and then, you know, the calculator rounds it off there, but technically it would keep going. All right. So that gives me the distance between the 2 points. Okay, now the second sort of guiding principle for this discussion is going to be how we represent functions so that we can use formulas like the distance formula. So, for instance, if I were to have a function, if I said, let's make the function f of x equals, let's do a transformation of something we've seen, like an x squared. So let's do x minus 2 squared plus 3. Okay, so that's a transformation of the graph x squared, right? That's a parabola, but it's shifted to the right 2 and up 3. Okay, so if you recall how that works with our transformations, so it's a parabola because it's got an x squared. Again, it's shifted to the right 2 units and up 3 units. That's our horizontal shift. And our vertical shift Remember, the horizontal is opposite of the sign that's in the parentheses. The vertical is consistent with the sign. And then that gives us our parabola. Okay, I'm sure I didn't draw that wide enough or too wide, who knows, but close enough. And so let's say we had that function. Now, how do I represent just arbitrary points on that graph? Well, an arbitrary point on that graph would be xy. But xy could be any point on the entire plane. It doesn't have to just be on that graph. So how do I specify a point is on a particular graph? Well, I think of this function in terms of y, and then I replace the y with the equivalent x, or the equivalent expression with x in it. Okay, so that point, instead of being x comma y, it's actually going to be written as x comma that whole thing, x minus 2 squared plus 3. Okay, so you replace the y with what it's equal to. This whole thing is what the y turns into. Okay, and we can use this representation here, x comma the function, in order to plug things in a general sense. So if I wanted to find the distance, for instance, between a point on this graph and another point, you know, maybe the point 4 comma 1, you know, I want to find that distance. Well, that distance is going to be different based upon where the point is on the graph. And so I can create a function for the distance, and the distance formula will have your x and your y values represented in this complicated way. Okay, so those will be the coordinates of the point, you know, when you try to plug them in. Okay, so the third sort of principle that I want to discuss is just some general geometry formulas. Okay, so some formulas for different shapes. I think as a foundational formula, the area of a rectangle is a big one. Okay, and you probably all know if you have you know, a length and a width, then the area is the length times the width. Okay, and there's reasons why that is the case, but the area gives you the amount of the space, a measure of the space on the inside of the rectangle. The perimeter is 2L plus 2W, so you add up the length, width, length, and width. It gives you 2 L's and 2 W's. And so these two formulas are going to be very important. If you were to apply that same principle to a square, remember, is a rectangle just with all four sides being equal. Then when you multiply the length times the width, you just get the side squared, right? It's length times width is side times side, side squared. And the perimeter, well, is 2s and 2s, which is 4s. Okay, so we have, that's for a square. So maybe I'll write the name of the shape here. Okay, so we got rectangle and square. Triangle can be built off of this as well. If you imagine a rectangle and I could inscribe any triangle, it doesn't have to be, it could be an obtuse triangle, an acute triangle, a right triangle, doesn't matter. Any triangle that I put into that rectangle will be precisely half the area. Okay, and you can see that if I were to draw a line and segment from the vertex parallel to the other two sides there, it splits this up, and so you have two smaller rectangles, half of which is inside the triangle and half of which is, so this half is inside the triangle and half of which is outside the triangle, right? And then over here, half of it is inside and half of it is outside. And so when you combine the two triangles on the inside here, you end up with exactly half of the total area because there's an equal portion on the outside of that triangle, okay? And so that tells us that the area of any triangle is going to be 1/2 the length times the width of the rectangle, right? Half the area. Now the length of that rectangle we call the base, or B, right? It's the base of the triangle. And the width of the rectangle is the height. We call it the height of the triangle. Okay, those are equivalent. So the base of the triangle is the same as the width of the rectangle, and the height of the triangle is equivalent to the width. Did I say length? I don't know. Base and length, height and width, they go together. I'm not sure exactly how I said that. And so you have 1/2 the base times the height, right? Length times width times 1/2. That gives you the area of the triangle. And of course the perimeter is just you add up the three sides. So the perimeter is, we'll call them maybe A, the base is B for base, and C. So you just have A plus B plus C. That's your perimeter, okay? So these are just some general geometry formulas. The other shape that's really important is going to be a circle. You'll see circles quite a bit. Circles are a little bit different because they don't have sides. So to calculate the area and the perimeter is done differently. I won't go through and derive where this stuff comes from. It is pretty interesting. However, with a circle has a center. It's, in fact, the distance. It's every point that's equal distance from the center. Okay, that distance, that fixed distance, is the radius. We'll talk more about that. The distance around the outside is called the circumference. On a sided shape like a rectangle, you add up the sides and call it the perimeter. This is not a sided shape. It doesn't have sides. It just has a curve around the outside. And so the distance around the outside is not called the perimeter, it's called the circumference. Okay, so the circumference is equal, well, I'll write the formula over to the side. C is equal to 2 pi r. Pi being the irrational number, approximately 3.1415, with an infinite number of other decimals that I don't know the details of. And so that's your circumference. Your area, the area of that circle, is pi times the radius squared. And of course, those two formulas can be derived, but I will not do that here. Okay. Okay, so that gives us some information about circles. Now, a little bit more detail about circles is going to be very important as we go. The first is this idea that a circle is a fixed distance from a central point. In fact, if I were to put that central point at the origin, so let's assume that's at the origin, and I can draw in a y-axis, and I could draw in an x-axis. Okay, so my circle is centered at the origin. Then every point on this circle is a fixed distance from the origin, right? And so this circle, we'll call it x comma y. The distance here, we'll call it r, to the circle is fixed. In fact, it's called the radius, right? So if I know the radius of the circle, then I could find the radius using, or find the equation of the circle using the distance formula. So, of course, the distance formula is right here, square root, oops. So d equals the square root of x1 y1, oh no it's not, it's x2 minus x1, I don't know what I'm writing there, x2 minus x1 squared plus y2 minus y1 squared. So that's the distance formula, okay? And so when I plug stuff in, if this is my x2, let's call it x2, y2, and let's call the origin here, that's 0, 0, we'll call that the x1, y1. So when I plug everything in, my x2 is x, my x1 is 0, and the distance is my radius. So I get radius equals the square root of x2, which is x, minus 0, and then y2, which is y, minus 0 again. Right? So we're getting the radius is the distance from the origin. And then if I simplify this, well, r is the square root of x minus 0 squared. Well, that's x squared. And y minus 0 is y squared. Right? So I get r is the square root of x squared plus y squared. And then simply, if I square both sides of this equation, I end up with r squared equals x squared plus y squared. This is the equation of a circle that is centered at the origin with a radius of r. So if I wanted to find, for instance, let's take a circle whose radius is 3. So it goes out to 3 here, to -3, -3, and 3. The radius is 3, centered about the origin. Then I would just need, well, 3 squared is 9. So the equation of that circle is 9 equals x squared plus y squared. Every point that satisfies this equation will be a point on that circle. Okay, so that's a general formula for a circle. We will come back to discussing circle equations more in more detail when we get into conic sections later in the course. But for right now, this general formula for a circle is going to be important, in addition to all the other formulas, geometry formulas that we just discussed.